Hey guys, welcome back to zedcargarage. As promised, today we are going to cover relocating the knock sensor on a 300ZX. This is my twin turbo model, and basically what happens on these is, at least on mine, is the wiring harness gets brittle, and you bump it or you try to relocate the connector, and it breaks. Actually, one of the wires breaks. And unfortunately, the knock sensor is buried up underneath the intake plenum, which is, I believe it's kind of right around in this area. So basically all of this has to come out, which will in the future. I plan on putting larger injectors, probably the 740cc Nismo, later on this winter. So at that time I will replace the knock sensor and route the new wiring harness down to its proper factory location. But in the meantime, this is going to be kind of a hack to get me through and at least have some sort of knock sensor feedback to the ECU. So as I mentioned in the lead up in the previous episode, I've got a wiring harness pigtail from Wiring Specialties. They've got an online store. I bought mine off eBay. And so what this is going to do is this end will plug into the factory harness, and then this end here will go onto the knock sensor. Hitachi was the original manufacturer of the knock sensors, and I noticed a very large price difference between the Hitachi and your knockoff brand. So this was, I believe, the cheapest I found. It was about $40 on Amazon, maybe 40 or 50. The knockoffs are in the neighborhood of $9. So I don't know, really what the big difference is, but obviously there is one, and so I didn't want to take a chance of having a faulty unit. All right, so we got our knock sensor, we got the new wiring sub harness, and so let's get under the hood and start doing this. So I first got the idea for relocating the knock sensor after I finished installing the Nistune, and I got a code 34. Apparently that's a big deal on these cars. It's quite common, and there's really what you need to do to determine if it's an issue with your sensor or the ECU is you come here to the connector. So this connection here is going back to the ECU, and right now I've got a 1 mega ohm resistor installed to basically fool the computer that the knock sensor is actually there. So if you ever need to basically get yourself through a tight spot like I did, just install a 1 mega ohm resistor across these two pins, and the ECU will think all is well. So let me first show you how to do a diagnostic, just to ensure that the wiring from the ECU to this connector is okay. I've got my multimeter here. Now on one of these connections is ground, and so I've got my multimeter set up to measure resistance, and I will just put this in the connector, not too hard. I don't want to damage or spread apart the connection. So one connection is supposed to read about 500k ohms. You see that's 0.57 meg. That's what the capital M is all about. So that's good. So that is the connection to the ECU. So that told me that I did not disturb anything when I installed the Nistune board. And now this one, on the other side, this should be ground. All right, I found some bad news. I saw something I didn't like, so I decided to pull the, the crossover tube. And on the engine side of the wiring harness, the knock sensor leads are also damaged. One of them you probably can't see, but you can just take my word for it that one of the wires is broken right there. So what I'm going to have to do is basically strip back the wiring harness into here and find where this wire is healthy, and try to splice this connector into it. And then that way I can come in with my new knock sensor sub harness, and still have a functioning knock system. All right, wish me luck. I think what we've got here is actually a shielded wire. There is a crimp connection where they've connected the shield to a normal wire basically, and then that normal wire comes over here to the connection, or to the connector. And so basically the wire is the piece that failed. I've got two options. I've got this little bit of wire hanging out, so I can definitely solder onto that. That's not a problem. The other thing I could try doing is disassembling the connector, push out this pin, and then solder. Basically get a healthy piece of wire in here. So I think I'm going to pursue that option first, and if I can't get this pin out of the connector housing, then I'll fall back to just simply soldering to it, and just being very, very careful with this, because it's extremely fragile. Alright, so I think, oh, I didn't mean to break it. Gosh, this thing is just so brittle. Yep. Alright. Dang it, I lost it. Okay. Now I believe there should be a little pin if I... Hey, got it. Awesome. Okay. So now what I can do is two things. I can, I think what I'll try to do is just simply pry this crimp connection away from this little rubber weather seal, and then get my new wire in here. I'll solder it. So I'm going to solder this pin up real quick. Notice a zip tie holding it. Hopefully if David Freiberger is watching someday, he will approve of that zip tie ingenuity. I'm going to try laying down a little bit of solder, so that then when I come in with my new wire, it's kind of got a nice little bed of solder to wick into. We'll come in here. Oh, there's the fire truck. Not my house. Okay. Alright, I think I can do better. I can see it's not a very good connection. This is really going to be tricky with just two hands. This is not very good technique, but I'm trying to get some solder. There we go. A nice glob it out on the wire, and then hopefully that'll kind of soak into the actual crimp connector. Alright, I think that's good as it's going to get. Again, this only really has to last a couple months. This is not going to be permanent. Okay, so now I can probably just let this cool a little bit, and then I'll see you back on the car. Okay.
try that again. I think that's the right way. Try the other way, just in case. Definitely seems to want to go in better that way. I don't think that is the right way. Dang it. I'm not careful. This thing is gonna just break. Okay, I might have too much solder on the backside. Let me clean it up. This almost looks like it does go the other way. Let's try it. It does. Interesting. Huh. Well, if that's the case, I wonder how I got it out. That's interesting. Let me just do a test real quick, make sure that pin is actually going to stay in. Yes. Very cool. Okay. So that's half of it repaired. So we got fresh ground wire coming up out of the connector. And now what we need to do is basically replace this factory section where things have just kind of gone rotten. This won't be a problem. I think what I'll do, just to save some effort, I'm just going to cut right here after this crimp, and then I will just simply put in my own crimp connection and call it good. I like how this episode went from being just a simple hack to much more in-depth open heart surgery almost. I'm hoping that that's not a recurring theme with this car, but I have my suspicions now that I've sort of seen into this car's soul, so to speak. I don't really like what I see, but it's fine. I like working on cars, so this is definitely going to give me plenty of opportunities to work. All right, so I could either solder this or do like what the factory did and just apply a crimp. I think what I'll do is use one of these weather tight crimps, which I don't know that's really really necessary here, but I will do it anyway. Oops. Slipped. Interesting. Will that go in here? Okay. When using these crimp connectors, it's nice to actually use the right crimping tool. You'll notice this one is color coded for the different size crimp connectors, and then it's even adjustable on the back side depending if you've got a butt connector, a spade connector, or a ring connector. Each one is slightly different because it's got a slightly different housing thickness, I would imagine. So this looks good. I can yank on it and nothing's moving. Now this one's weather tight because you can actually come in with a heat gun, and this will cinch around the wire. So I'll get my heat gun. Alright, now at this point I can finally do what I had set out to do originally, which is relocate the knock sensor to one of the bolts back here on the rear of the intake. This is actually 12 millimeter back here. Now, what will be interesting too is if this is actually long enough. This looks relatively short. I can kind of see by the threads that I don't have a whole lot of engagement. I may need to buy a longer bolt. So let's just test fit this here and see how many threads I got. Yeah, 0. Tomorrow, it's getting late, I will need to basically get a bolt that is, I don't know, probably about 20 millimeters longer. I've got a good hardware store nearby that will have this. I may even have, let me check my, my own hardware. Okay, no luck, but that's all right. I will just go ahead and start putting everything back together. All right, it's a day later. I just got back from the hardware store. I needed to get a longer bolt to accommodate the knock sensor. So this knock sensor is about 20 millimeters thick, and then by adding another 20 mil to the bolt, that will give me enough threads to actually thread into the lower intake manifold. So again, I'm using the rearmost hole in the plenum, and I checked on the Z32 wiki for the torque spec, and this needs to be 12 to 15 foot-pounds. Okay, there we go. When I was doing the final editing, I realized I'd forgotten to show the final product. So right here is where the new knock sensor is located. This is the new bolt, the new longer bolt. And then here is the new sub harness that will go back to the engine computer. Next time on zedcargarage, I'm going to go over installing the Innovate SCG1 electronic boost controller. Let me show you real quick what's all involved. Okay, under the hood there are 3 major components. You've got your boost solenoid, which is going to be controlling the wastegate. We've got our map sensor, which will be measuring the pressure that the turbochargers are producing. And then sort of unique to the Innovate system is the wideband controller. So this is going to go off to a wideband sensor underneath the car. The Innovate SCG1 also has the solenoid controller gauge.
So this is going to display air-fuel ratio along with boost pressure and then also the status of the system. You can also see I got started on the wiring a little bit, and I will go more into detail about what all the wires are and how I routed them when we get to that part of the series. Thanks for watching. Really appreciate you guys. Please like and subscribe, and see you next time. Thanks.